So here's the language we want to implement now. The grammar of the language is the same as always as our minimal lambda language. We have numbers and identifiers, addition and multiplication, functions that take a single argument, and calls to functions with a single argument. So what's going to make our new interpreter different from the old one, however, is that we want a lazy evaluation order. If we have a function call to a function that takes an argument and ignores it, then it doesn't really matter what the argument does. It's going to get ignored, and so in this case we just produce 0. On the other hand, if our function takes the argument and uses it in order to get the final answer, then we will need to evaluate the argument, and so an error will happen in this case. Our interpreter is going to have a let form that is just a sugar for using this lambda application pattern. So even if we write it with let x be this expression that produces an error in 0, we're still going to get a 0 because this expression is exactly equivalent to this first expression here. To implement this, I'm starting with our lambda interpreter. That is just lambdas with environments. I've dropped the let c and included the sugar form of let that expands to lambda c so that we get down to in interp, we just have lambdas and applications and so on. And our goal then is to have all the things work as they did before, because none of our tests really depended on eagerness or laziness before. But now I'm going to add some more tests. I want interp of parse of a lambda that takes an x and just returns 0, applied to 1 applied to 2. That would be an error. In an empty environment, right now that raises an error that 1 is not a function. I want to change this so that that gives me just a 0 out. So I'm going to have a new test case that says, in this case, laziness means that we get a num v 0 out, not an exception.